So before moving forward in the video, I have an important announcement for you. So if you're somebody who is actually willing to learn advanced backend technologies, then this is going to be the right platform for you. So at Algocamp, we have launched our new flagship Lambda 4.0 Advanced Live Backend Development Batch, in which you are going to learn advanced backend technologies including Fastify, Express.js, AWS, Mongo, DynamoDB and whatnot. This is going to be a power packed course in which we are going to take you from the very scratch, very basics of backend technologies to the very advanced level by building a lot of interesting projects. We are going to build projects like Code Sandbox Clone. We are going to build streaming app which will include recorded movie streaming plus live streaming as well. We are going to make applications like booking.com backend, which is going to help you understand transactional capabilities, integrations of payment gateways and many more. All the important projects that we are going to cover in the course is going to be listed here, and this is going to be an absolute live course where we are going to take live classes, right? And in these live classes we are going to do hands-on coding experience to learn all the important advanced backend technologies. You already know that backend is something that every important application needs, and you can actually excel your software engineering career with these backend tech in the Node.js stack. So what are you waiting for? All the important links, the complete syllabus, curriculum, all the details of the course is present in the description section below. You can use the coupon code coming up here to get maximum discount off on the current price. I'm really excited for the course. I hope you guys are too. And now let's get back to the video. So now we already know about two important solid principles, that is single responsibility principle and I would say open close principle. Okay. Now, before we move ahead, I would like to take up an interesting problem. Okay. I would like to take up an interesting problem and we'll try to solve that problem, because without problem solving, understanding these concepts might not make a lot of sense and will not give us that amount of satisfaction as well, right? Because once we understand the problems that can come to the code in a real life scenario, that helps us to retain all of these things as well. Okay, so let's start. So what I'm going to do is I'm going to create one more example folder. Okay, and this is this problem that we are going to start with is a problem of a, I would say, very famous. It's part of a very famous interview problem. Okay, if you are going to give a low level design interview, or let's say you're going to be involved with any kind of a low level design discussion, there is a highly likely chance that you will definitely see this problem coming up ahead. Okay, so we are going to talk about that. So this famous problem, and eventually we are also going to code this complete problem end to end, but I would like to just take a part of this bigger problem. What's the bigger problem in hand? So a lot of times in low level design interviews you will be expected to code different type of games. If you ask me, I have been asked to code the snake game once, right? Like snake game, not the UI part, but of course the logical aspect of the snake game, how will you build that up and so on and so forth. A lot of friends of mine have been also asked to code a couple of games like Connect 4, Tic Tac Toe and so on. And one more such game which can be pretty interesting and hard if you have not practiced it earlier is chess, right? Everybody must have played chess. If you have not played chess, trust me, try once. It's a very nice game to play. Okay, the interesting thing is that coding a complete chess game yourself can help you understand um, a lot of concepts around low level design. Of course, there are some algorithmic concepts as well around these games, right? If you try to code a snake game, then of course there are a lot of algorithmic concepts that will come into the picture. But coding a game like chess can be very interesting for your understanding, and being a very famous interview problem, this gives you a good, I would say, explorations scenario as well once you are practicing low level design. But today our agenda is not to code the complete chess game. Instead, I would like to take a specific part of this particular chess game, which is kind of like the building block of the chess game as well. I'm talking about the pieces in chess, right? I'm talking about pieces in chess. So let me open my notes. Okay. So how does a chess game looks like? Let's start with that. Okay, so we are doing a bit of discussion around chess. Okay, and it's fun. Chess is fun, right? Cool. So the two major things like that exist in a chess game is a chess board, of course, right? Chess board, without a board there is no chess. But apart from the chess board, one more important thing in the game of chess is the chess piece. Okay, is the chess piece. So generally you will see that there are a couple of rows here and there, and in each cell you have a couple of pieces added, right? So if I just draw one side of the game, like maybe if you see with respect to white, okay, and 2 3 4 5 6 7, okay. So generally how things are done is on the very edges you have rooks, right? So I'll take one more R and we'll put the rooks. Okay. Now in the center, and apart from rooks, you have one very basic piece which is your pawn. Okay, which is your pawn. So I'll put pawns here, right? I'll put pawns here. Okay, cool. Right. Apart from pawns, you have knights. Okay, you have knights. So I'm representing every single piece via character. And there's a very important, like why I'm doing all of this, why not just open chess.com and show is like once you start drawing, the moment you start drawing, you will get a lot of ideas to code as well. Like for example, you might be thinking, oh, in a chess game there are like those very nice piece symbols and everything. How will you get that in your, let's say, Java code or Python code? So good alternative would be to just have characters, right? So that's why I'm also putting characters in place, right? So we'll, let's say, put a K for the knight. Okay, if I remember correctly, knights are placed here. Then you have bishops, right? Then you have bishops. So you put B bishop here. Let's put a capital B. Okay, you have bishops. If I'm correct, bishops are placed here, right? Okay, and then you have a queen and a king, right? So you have a queen here and a king here, queen here and a king here, right? So these are the basic set of chess piece characters. In case you do not recognize with the characters, I'll just show you the chess board also, right? If you see chess images, then you can see the board looks something like this. Okay, we have drawn it correctly. You can see this piece is called as the rook. This is your knight, which is, a lot of people say it as a horse. Horse is the wrong term, it's a knight. These are your bishops which go diagonally. On the white side you have queen first and then you have a king. Okay, now an interesting thing that you see now, if let's say the problem statement is just to think about chess pieces, okay, just to think about chess pieces, that you have to write a class for a chess piece. That's the only thing that is the problem statement. We are not designing the complete chess as of now. As I mentioned, we will be talking about the complete chess game later. But for now, I would like you guys to just think about, if let's say you have to write a chess piece class, write a class chess piece. Okay, write a class chess piece. So what are the things about a chess piece you can think of, right? I would like you guys to pause yourself. Think about, if let's say you have to write a chess piece class, what are the things that you feel are nice to have in a chess piece class? What are some of the caveats that you can think of? And then we can maybe continue our discussion on this. So if this problem is given to you, there is a highly, like in an interview, and there is a highly likely chance the first thought that will come to your mind is, okay, we have to design a chess piece class. Okay, let's take it up. Let's take it up. Most of the people will choose among these, one of these kind of like things, right? So let's start talking about it. If I say chess piece, right? If I say chess piece class, okay, what most of the people are going to do is they are going to definitely keep a position parameter, some xy coordinate, right? Some, let's say, coordinate, some way to represent a coordinate xy, right? For that, people can keep a row column. Different ways are there to keep it. Okay, but probably there is a highly likely chance that you might have think about a coordinate to keep, right? Some way to keep the corresponding coordinate, right? Apart from that, probably you might be thinking about some color, a color property you are going to keep, right? Good chances you are going to keep this color as an enum, right? If you are like at least appear like if you are an experienced SD1, at bare minimum you will think about color as an enum, right? Apart from that, a couple of people might have also thought about character representation of let's say the piece, that every piece will be represented by a character. So maybe you are going to keep character name, right? That K represents a knight, R represents that, so on and so forth. Okay, these are kind of like the bare minimum set of things that people will think of. Okay, and we'll start preparing this class. Maybe if you are thinking a bit more, somebody might have think about a function move, like these are the class properties. As a behavior, people might have thought about a move function, that the pieces can move. Okay, cool. Now, what are the problems with this kind of a class representation? What is the problem with this kind of a class representation? The problem with this kind of a class representation is how a chess piece moves is dependent on the type of a chess piece. So, if the chess piece move is a bishop, then bishop moves diagonally like this or like this. If the chess piece is a rook, then rook moves perpendicular, like straight line in vertical and horizontal both directions. If you are a pawn, you can only move one step forward, or maybe if you have a position to cut somebody, then you will move one step diagonal, and so on. The thing is, this class directly violates single responsibility principle, and that is not the problem, and that is not how you should approach a problem. Whenever you are thinking of a class, it's your responsibility to think, are you violating SRP? It's a direct violation of SRP. Why? Because now, how will you set up the move class, move function? Probably your move function is going to look something like this, that if this dot name is equals to, let's say, R, then you are going to have some kind of different movement. Else if this dot name is equals to, let's say, what, B, okay, then you are going to have a different movement, and so on, right? And it also violates OCP. It also violates OCP. How it violates SRP? Because one chess piece class is doing the responsibility of every particular chess piece. It's doing everything for the chess piece, right? And how it violates OCP is that, let's say, if we extend some form of new, like I'm not sure how many of you guys know that, but chess also has a lot of variations, right? So if you go with a different variation where a piece does something else, like you have a modified bishop which can do maybe something extra, then you have to add a lot of things in your code. So both SRP and OCP directly violate, so it's a wrong answer. Like it will be like straightforward wrong answer. SRP gets violated in one more fashion. SRP gets violated in one more fashion, which is, apart from moving a piece, piece does a lot of more things, right? For example, there's a like whenever you are going to move, there can be one more function of can move. Like, can you even move? Whatever direction you want to move, can you even move to that direction? Right? For example, let's say if you go in a game of chess, like probably you are thinking, hey, I'll move my knight. Okay. For example, let's take this position. Okay. So this is the position where this black rook has given a check to the king. You might want to move your knight, but can you move your knight? You cannot move your knight. You cannot move your knight. Why? Because your king is under a check. You cannot move your rook because your king is under a check, right? You cannot do anything. The only place that you can move is this. So even you can move a piece or not, this is also dependent, right? So there might be a function can move, right? Something like this. Okay. Apart from this, in the game of chess, whenever a pawn reaches the ninth rank, or let's say the last row, the pawn can promote. But if a rook reaches the last rank, it cannot promote. So promotion logic also will go in your chess piece class. Straightforward violation of single responsibility principle, right? So you can see, if you start your interview with very less thoughts, then you might end up in a class which is kind of like a monster class, which is doing a lot of things. And that's why these games like projects are very interesting to build up, because this gives you a chance to think about a design as carefully as possible. Now, considering the fact that now you know that, of course, our class design is not the best, no problem, you are here to learn. So the moment I'll say, oh, open close principle is getting violated, immediately a lot of people will think, let's not have one chess piece class, okay? A lot of people will start thinking that maybe another possible design can be, why all of this is happening? Because the chess piece contains a character name which represents the type of the piece. So what if I modify this class and make it kind of like a parent class, okay? And let's say we have a couple of child classes, right? This will be the next design. That the moment I will say that, hey, your design has this problem, assume I am the interviewer, and I immediately tell you that, okay, this is the problem with your design. And let's say you are able to figure out that, oh, open close principle gets violated, because interviewer will give you a hint, like how will you write the move function. You will see that, oh, I'm writing the move function like this, it looks like open close principle is getting violated. So what you are going to do is, you are going to propose a new design. This new design will be even more interesting. Let us see how. So what you will say is that, okay, I'll make this chess piece as a parent class, and I'll be having a couple of child classes, like a pawn, okay? Then I'll be having one more child class, let's say a rook. One more child class, let's say a knight, and so on. Okay, let's draw one more. Let's say a king and a queen, etc. Like a lot of them, right? Lot of child classes you are going to build. The moment you do this, you will say, hey, we are on the road or on the way to resolve our open close principle problem. Because now, if not just the traditional pieces, even if we have some modified pieces, like now let's say you have a modified bishop in a new version of chess, where the bishop can also move like a knight. So you can write a new modified bishop also, and just extend from this particular class. Okay, right? This looks fine. That, okay, now the behavior of every single piece is now segregated in their separate class. The moment you do this, of course, you have solved the problem of open close principle at some level. Even single responsibility principle can be now even in a better state, right? The single responsibility principle can now be in a better state, of course. But there can be more problems with this particular design. What are some of the problems with this particular design? Let's think about it. Okay, let's think about it. So let's say for a moment you are going with inheritance, and let's say this is a move function, and let's assume that you have an abstract class. This chess piece is an abstract class. Okay, for a moment, assume abstract. Okay, right? Abstract. The moment you make it abstract, of course, now you cannot make a chess piece object. Only you can make objects of these concrete classes. Okay, and let's say you have this move function, which is an abstract method. That means you have to override this move method in every single class. You will override this move method here. You will override this move method here. You will override this move method here, and so on. based on whatever is your piece movement scenarios, you can technically move this particular piece. Okay, looks fine, right? Looks fine. You will be implementing moves for every single corresponding piece. And let's say that this move function is going to expect us with an argument that we are at a position which is representing by the current coordinate, and we want to move to a destination x and a destination y. So we need a coordinate that I want to move from here to here. Like, where do we want to move to? So this destination x and destination y will be, let's say, the I would say coordinates where we want to move. Okay. Cool. Now, is there any problem with this particular design? Assuming that open close principle also looks somewhat in a good shape. Open close principle also looks somewhat in a good shape. Is there a design flaw here? Now, what is the problem with the current structure? To introduce problem with the current structure, I will also introduce, let's say, one more function. I will also introduce one more function apart from move. So both the functions will be having two examples to understand this. One is a move function, and there is, let's say, function called as castle. What is castling? What is castling? I'll show you with maybe a video. Castle king gif. Okay. I'm not sure how many of guys and girls have seen like castling in chess, but this is how castling goes. Like king and rook are like swapped. Like I'm not sure if you guys have seen that meme as a right. So if there is no one, so what is castling? Okay, what is castling in chess? It's not an advanced concept. If you don't know chess and you are thinking, oh, like we never heard about castling, it's because you don't know about chess. It's like basic of chess. Okay, so you will be expected to know basic stuff, right? So how castling works is that, let's say if there is a king and there is a rook, and king has not moved from its place, plus king is not under a check, then king can directly see its same color rook, and king can direct, that means no pieces are in between, and there is no attack on the part. So there are a lot of rules. First, king should not be under check. Second, the king should not have moved previously, it should be on its original position. Third, the path should not be attacked from anywhere, right? For example, there should not be a queen on the column C which attacks the column C, for example, and so on. So there are a couple of rules. If all of these rules satisfy, then the king and the rook can swap their position. This is generally done to make a king safe. Okay. So let's say there is a function castle also that we have. So if this function castle is there, right? And there will be more castling related function like is castle. Okay, more similar function, but let's say there is a castle function also. Now, because you have, let's say, made an abstract class. Okay. So let's think with respect to both of these functions, move and castle. I hope the basic logic around castling is making sense to everybody. Now, considering that we know about it, let's think about both the functions one by one. Okay. Now, if I keep a castle function in the chess piece class and expect it to be an abstract function, and we are going to override this in every single class. We are going to override this in every single class. Now, the problem with castling is that not everyone can castle. Only king and rook is involved in castling. And to be very honest, castling is related to a king only. And it can swap a place with the rook. The rook cannot trigger a castling. This is a rule. Okay. This is a rule. Let's say you don't know about this rule in an interview, but the interviewer told you this rule now. Okay. Let's say you know nothing about chess. And now in the first 5 minutes, he gave you all the basic rules of chess. So you have to think accordingly. Okay. So even if you don't know about castling, I'm telling you that castling is triggered by a king. Castling is not triggered by a rook. So technically, inherently, it's a king related property. But we can still give rook some level of significance that it is okay, it's part of castling. Okay. But other pieces has nothing to do with castling. The other pieces have got nothing to do with castling. Okay. Other pieces, like they don't even need castling. Okay. So if you have to technically override castling. What are you going to do? You are going to, in king, you will write some nice algorithm, do all the checks and do the castle if it is possible. But what about a knight class? What about a pawn class? You will be forced to write an implementation where probably you are going to throw an exception, right? You are going to probably throw an exception, right? Okay. Similar thing will happen with move. Similar thing will happen with move. Okay. For example, you can give king some coordinates, and if the king can move to that coordinate, it will move to that coordinate. Otherwise, uh, it will say that, okay, it's not a valid coordinate to go for, right? Okay. The problem comes, and similar thing with knight. Like if you can go to a coordinate, then you will go to the coordinate. The problem comes with the pawn class. The problem comes with the pawn class. In the other classes, if you can move, you will move. But if you cannot move, then you can just throw an exception. You can just throw an exception that invalid move. You can write your new exception class invalid move, and you can just throw that exception. Okay. Problem comes with a pawn class. Problem comes with a pawn class. In a pawn class move function, right? If somebody gave you the x coordinate, if somebody gave you the x coordinate which is behind you, if someone gave us an x coordinate which is behind us, then it's an illegal argument. It's an illegal argument, right? Because think about with respect to a rook can go to, like, there are situations in which rook can probably go to every single cell until or unless somebody is sitting on that cell. But even if somebody is sitting on that cell and if they moved, then they can go to that cell also. Rook, queen, knight, they can probably go to all possible cells. But that's not the case with pawn. Pawn can never go to a cell which is behind itself. In any situation, it is not possible. It's an illegal argument for a pawn, right? If let's say due to any reason, like rook wants to go to a cell and at that cell its own king is present, so you will say that invalid move. But the arguments are not invalid. It could have gone to that particular x and y where the king is sitting, but currently it is not able to go, so it's an invalid move. It's not an invalid argument. For a pawn, it's an invalid argument. For a pawn, it's an invalid argument, right? Moral of the story? Moral of the story is, in both move function, castle function, there can be more functions where, like, you said that a chess piece can castle because you kept the castle function here. You kept the castle function here. You kept the castle function here. You said a chess piece can castle. That means you are saying a pawn can castle, rook can castle, knight can castle, and king can castle. But can everybody castle? No. Pawn will throw an exception, rook will throw an exception, knight will throw an exception, but king will not throw an exception. King can castle if it is able to castle. But for a knight, it's an invalid move to castle. Like, there is no theory to castle a knight. Same thing with move. Some pieces can, like, normally move or will throw a invalid, some will throw a invalid move exception. But pawn is a special, I would say, piece which can also throw a illegal argument exception, right? That you have given a wrong argument altogether. Moral of the story is that the way we have designed the classes, is actually forcing us to do a couple of implementations, right? And this directly violates the third solid principle, which we know as Liskov substitution principle. Liskov substitution principle. Okay. Right. I'm not saying these exceptions should not be there. I'm saying there could have been a better way. There could have been a probable better way to technically design our classes. That's what my I would say argument is. That's what my argument is. Okay, that there could have been a better way, right? And that's why I gave you both of the example. That in the move example, still you can maybe argue with me for a couple of things, but in the castling example, though, you cannot even argue. In the castling example, you cannot even argue. Okay, so this is a direct violation. Whatever we just saw, this is a direct violation of the third, that stands for the L, that stands for our L in our I would say solid principles, which is the Liskov substitution principle. What is the Liskov substitution principle saying? It says that objects of a child class, should be as is substitutable, right, in the variables of a parent class, right? Objects of a child class should be as is substitutable in the variables of a parent class. What do I mean by that? I mean that, let's say if you create a chess piece, K is equals to new king. Then you create a chess piece, small k as new knight. Then you create a chess piece pawn, p1 is equals to new pawn, because there are multiple pawns, so I'll just say new pawn. Okay, and so on, right? Ideally, what we are saying is this kind of a thing should be pretty smooth. If we want to do something like this, then our code should be written in a way that if we want to do something like this, it should be pretty easily doable. But is it currently easily doable? No. Just two behaviors we have seen, and you can see we have to do a lot of custom handling. For example, now if somebody called p1.castle, it will throw an exception. But if somebody called k.castle, it will not throw an exception. Either it will castle or it won't be able to castle, right? So we cannot just directly call the castle function here, right? This is kind of like not directly possible. Same thing with move. Move sometimes will properly move or give you a invalid move exception. That's obvious according to your business logic. But sometimes move can also give you a illegal argument exception. Right? Now you will say that, okay, we will custom handle it. But think about a game of chess. I have just given you what? 2 rules, and you have already started with your particular set of design. You have already started giving so many customizations. You have already started doing so many customization with just 2 rules. Think about it with respect to a game of chess. Game of chess has got humongous number of rules. If you just keep on, I would say, changing your algorithm based on new rules, then your code will be very bad every time. And I'm saying there are variations as well. Variations of chess is also available. If there are variations as well, then think about it, how cluttered and bad code you are going to write. And if you want to see that whether you are writing a bad code or not, these solid principle helps you. So you first of all checked, is there too many responsibilities? Yes. Is there I would say modification being allowed and extension not possible? Yes. Now this will be the third statement that you are going to check in your code, that are the objects of the child class as is replaceable by the parent class? No. Like you said, chess piece can castle, but not every chess piece can castle, right? You don't want to be in a situation like that, right? That you generalized, because you put it in your abstract class here. You generalized that, okay, chess piece can castle, right? Chess piece can castle, but your chess piece is not able to castle. Now, if I would not have given you the move example, immediately somebody would have come into the chat and said, hey, why are you keeping the castle function in the abstract class then? King only needs to castle. Only king needs to castle. No. Keep the castle function only in the king class. That is the child class. Don't even keep the castle function in the parent class. Then only king can castle. I'll say, okay. But what if apart from castling, there is some other move. Apart from castling, there is some other move which can be only done by king and a queen. Then what will you do? Are you going to keep those two functions, just those two functions, in the king class and the queen class and not others? And then let's say there is a function that can be only done by rook and a knight and a queen, not others. So you have one more function that you are keeping in rook, knight and queen. And let's say the function implementation is also same. Let's say the function implement, like the logic is also same. Then are you going to copy the logic in rook, knight and queen? Things will start going out of hand, right? Things will start going out of hand. So now we know our class is violating the Liskov substitution principle. Okay, there can be more examples. There can be more examples in which Liskov substitution principle can be violated. And to resolve Liskov substitution principle, generally we have to do a couple of restructuring here and there. We will also see the restructurings that we are going to see eventually in the chess piece class, but you have to do a lot of restructuring, right? One more example that let's say I can give you is, for example, let's assume, okay, let's assume that and we wrote a class related to this as well, I guess. Yeah, you can see there was a HTML converter kind of like class that we wrote, which we segregated into a text processor class and a file processor class, right? The text processor class was taking a file and it was converting the text of that particular file, right? It was converting the text of that particular file, right? Think about with respect to this text processor class. Okay, currently this text processor class is doing what? It's converting an HTML, it's converting a text to an HTML, right? It's converting a text to an HTML, right? Okay, let's say we want to extend this class, or let's say we want to add more functionalities, that now we have a markdown and I want to convert my markdown also into a HTML. So currently what's happening is our text gets converted to HTML. I want to extend the functionality that, let's say later, now we can also have markdown converted to HTML. We can have markdown converted to HTML as well. Let's say we can have JSX converted to HTML as well. These are all different markup formations. Okay, and so on, right? And so on. For example, there is a resume writing, I would say, template also, right? For example, if you go to overleaf, right? If you go to overleaf, so in overleaf you can write something like latex, which is also a markup, right? So let's say you want to have a latex to HTML converter as well, and so on, right? You can have multiple converters. So the immediate thing that you will be able to see is like, okay, the text processor class is kind of like something like this. So what if we change our design, right? Let's try to change our design in a way such that we are able to accommodate to more processors, like we are able to accommodate for more processors, right? Because we can have a HTML processor, we can have, let's say, markdown processor, right? We can have more different type of processors, right? We can have a lot of different type of processor. So what we can do is, let's say we have a abstract class, right? We have an abstract class text processor. Okay, sorry, abstract class HTML converter. Like, let's name this abstract class HTML converter, and inside this abstract class we are going to have a method convert text. Okay, let's say you have this method, and this method is, let's say, overrided. This method is, let's say, overrided by text to HTML converter class, which extends HTML converter. This method is also overrided in markdown to HTML converter class. Markdown to HTML converter class, right? And then this is also let's say latex to HTML converter, right? Simple thing, right? Simple thing. Okay, now let's take our problem one bit ahead, one step further. Let's take our problem one step further. That, let's say, this design is good, but now we have a new problem. Let's say we have a new problem. Okay, in this problem you can see making an abstract class was pretty nice solution, because you can see here the moment you made an abstract class and you just directly moved straight forward to the solution, it caused a lot of problems. But you can see here the Liskov substitution principle is not going to be violated. You can see in this kind of a design, the Liskov substitution principle is not going to be directly violated, right? Because we expect finally HTML conversion from convert HTML. Let's call it as convert HTML, right? We'll write a function convert HTML. So whenever we have an object of HTML converter, doesn't matter the type, text to HTML, markdown to HTML, latex to HTML, it will eventually create an HTML, right? There is no ifs and checks and buts, at least like at like bird's eye view, we are not able to see. So this kind of a design is technically following our Liskov substitution principle as well. Okay, cool. So here we saw that when Liskov substitution principle was being violated, here we saw that, okay, Liskov substitution principle is getting followed, right? Now let's come back to our chess example. Okay, let's come back to our chess example. Now, as I mentioned, there was one more requirement for our chess problem. There was one more requirement for our chess problem, that currently chess is nice. Like rook is having a separate perpendicular moves. Knight is having, let's like the L type of a move, right? Pawn can move just forward or like once crash diagonal. King can have like just a square boxish move. Queen has diagonal and straight moves and so on. Everyone has decided set of moves. But let's say you want to be in a situation where you can design a new chess game as well. That is a modification of chess game, that in some world, a rook can also act as a rook and a rook can also act as a bishop. Okay, although if a rook is acting like a rook and a bishop, it becomes a queen. But let's take another example, that rook can work like a rook, but it can also work like a knight. Okay, so interviewer gives you this requirement, that in a new world of chess, you can have customizations, right? You can customize your piece, that maybe rook acts like rook plus knight. Rook acts like rook plus knight. Okay, rook acts like rook plus knight. Queen acts like, let's say, queen plus knight. Okay, maybe knight acts like bishop plus let's say bishop plus let's say king, and so on, like some random customization. Let's say this is also something that you want to do, and not just two, maybe more. Queen or let's say king acts like everybody. Pawn, that means it can cut diagonally and everything. Queen, bishop, knight, etc. And maybe there is some custom movement also you have to introduce. Maybe some custom movement you have to also introduce, right? So let's say this is the requirement. Now, if you see the current design is also not able to cope up with that. Not just Liskov substitution principle. If you see the current design, it cannot also cope up with that. Okay. And I will give you one more example where if you see make current type of design, it will not be able to cope up with this kind of a I would say requirement. Now, very similar to this kind of a design, you can have one more type of a design. Okay. For example, let's say you are making a payment system. Okay, let's say you are making a payment system. New folder, example 6. Okay, the chess example I have not added here. This one I will add, because the chess example needs a lot of more interesting stuff. But let's say I'll add a problematic code, and I'll write a better code. Now, payments are pretty crazy systems to work for. Let's say that you are having a credit card class. New file, credit card .java. Okay, let's assume for a moment that you have a credit card class. Okay, pretty straightforward Java class. And let's assume for a moment you make it abstract also, right? You make it an abstract class. Let's write some properties. Private string card number, right? Card holder. Okay, Then let's say CVV, expiry date, CVV, like these basic properties. Okay. Then there are some functions, right? For example, there is, let's say, private void, let's say, or let's say not private, let's say, let's make it protected void set card number. Okay, set card holder, set expiry date, set CVV, like simple setters getters. Okay, so instead of writing all of this, I'll just write a comment setters, getters and setters. Okay, so assume that you have getters and setters. Okay, cool. Now, nowadays credit cards are crazy, right? You can make a lot of different type of payments through credit card. Now, you can make a abstract function, public abstract void, swipe and pay, right? You can swipe a credit card and pay, right? You can do refunds on credit cards. Okay, you can do abstract void, let's say online payment, online transfer or online payment, right? If you don't want to swipe and pay, and let's say you want to go to Flipkart and like just pay on Flipkart, right? You can do that with credit card also. Very nice. Public abstract void. Now, apart from all of this, you can also do tap and pay, right? That you just go to the machine, instead of swiping, instead of online transfer, you just tap and pay. Interesting. Then apart from this, you can say public abstract void. Nowadays with credit cards, you can make UPI payment also, right? Things are going to go interesting, and so on. More methods are there. Okay, more methods are there. Now, why I'm making this credit card class abstract? Because if you see credit card technically is nothing. If you just make a credit card class, is nothing. Why? Because if you think about actual world, in actual world, credit card is actually driven by the issuing company, not the bank. Bank like ICICI Bank issue the card, but the transactions, the algorithms, the transfers are all driven by the credit card issuer company, which we also call as the network of the credit card. What are the network of a credit card? So a credit card can be a Visa credit card. A credit card can be a Visa credit card, which extends your credit card class, right? And you can see it's violating all of this, right? So what you are going to technically do is you are going to override. Similar to Visa credit card, you can have new file, MasterCard credit card .java, extends, let's say, credit card and overrides its own set of functions. Then you have RuPay credit card. It extends credit card, RuPay credit card, extends credit card, and then similar kind of overridings will happen with RuPay credit card as well. And one more I will add, Diners credit card. So there is one more network, like I'm not sure if you know about it. Diners Black is a network, right? Diners credit card, let's say, extends, and this, technically there is one more, MX credit card .java. Okay, MX credit card is also a credit card, right? We can do extends credit card. Now you might be thinking, what's problematic with this design? This looks pretty nice. It is not nice. Why? Let's go with our favorite UPI. UPI is not supported on Visa, MasterCard, Diners and MX. You can only do UPI on RuPay cards.
Sad but true. Right? As of now, you cannot do UPI payments apart from anything around RuPay card. Okay. The moment I say, again, somebody will come into the picture and say, oh, it's a strict behavior to RuPay. So let's remove UPI from here. Let's remove UPI from everywhere, no? And let's make it a specific property of RuPay cards. Somebody will definitely think about it in an interview with respect to this term. There are two significant issues with this particular type of an approach. There are two significant issues with this particular type of an approach. First, currently only RuPay card supports UPI payment. What if the government of India mandates that if any credit card has to work, eventually they have to support UPI? Because government of India has done a lot of things in finance to enforce a lot of things. So maybe they does. The moment they do it, your design is out of question, right? You have now gone back to the original situation where you have UPI payment everywhere, right? Where you have UPI payment everywhere. And let's not even have like this. So recently I was at a store in Bangalore and I heard a very interesting statement that even I was not aware of. But most of the time, these situations will be given to you by an interview. That this do refund function, no? Diners Black doesn't support refund. Okay, I'm not sure how much true this is because I don't own a diners. I heard it on the cash counter of a very renowned and very big store that if the storekeeper was telling, like the cashier was telling that, sir slash ma'am, if you will pay via diners and you later come for any kind of returns for a refund, we won't be able to process a refund for you. We can give you an alternative item only. But if you pay via anything apart from diners, refunds are possible. That means diners will probably throw an exception for refund. Master, RuPay, Visa, MX will not throw an exception for refund. Right? Okay. Then more situations like now just think about it. Just with refund and UPI payment, things are so crazy. Now, think about, let's say there is a function international payment. Now this is also a very interesting case. Public void international payment. Now let's say international payment is not available in RuPay card, it's available everywhere else. It's not available in RuPay card, but it's available everywhere else. So we have to do override and let's say international payment, and we have to implement an international payment everywhere. So this is what diners and so on, right? And so on. Everywhere you have to add. Everywhere you have to add. So I'm just adding the same one, but everywhere you have to add. Okay. Cool. Now, just think about it. Let's introduce a scenario. Okay. Let's introduce a scenario. Let's say for international payments, MasterCard expects a PIN, but Visa, Diners, and Amex do not expect a PIN. If you will do an international transaction, you will realize that a lot of times you will not be expected to put any PIN. I'm just putting a hypothetical example here that maybe MX, MasterCard, and MX, Diners, and Visa expects a PIN. Doesn't expect a PIN. MasterCard expects a PIN. And RuPay to can't even do international transaction. So for RuPay, you have to throw an exception. Throw new unsupported operation exception. Right? You have to throw an exception from RuPay. The overall problem is that this solution is not very much extendable because the features are segregated in such a way. The features are segregated in such a way that some features are common. Some features are present in a few classes but not in the other class. Like UPI payment was still okay, you could have copy pasted, but I told you the issue that maybe everybody else also has to implement a UPI payment. International payment, RuPay doesn't support. Other supports, in which a club of them supports in the same way, but other one has a different algorithm. So are you able to understand this design is not extendable? Why? If you think about international payment, the same algorithm is done in Visa, same algorithm in Diners, same algorithm in MX, but a different algorithm in Master and exception in RuPay. So it has created two type of problems for us. First, of course, it is violating some level of Liskov substitution principle. Plus, there is a lot of code duplication going on. The the core algorithm of international payment inside Visa, Diners, and Amex is going to be same because everybody requires no pin. But MasterCard requires a pin. So here there will be an additional step of pin. Rest everything is going to be same. Right? This kind of a classes, this set of, and you can see similar problem was here also, right? That your behavior is pretty much segregated, right? Your behavior is pretty much segregated. If you previously see like your first implementation, your behavior was very much like in this first level implementation, what you were doing was your behavior was very tightly coupled to your class property. Ideally, your behavior should not be very tightly coupled to your class property. That you segregated here, but still, if your behaviors have a lot of cross combinations, then also it's a pretty problematic scenario, which goes forward and violates our fourth principle, interface segregation principle. Okay. Right. What is interface segregation principle? Let's talk about that. ISP. Okay. ISP. Pretty simple. Okay. Interface segregation principle states that if any particular member isn't intended to be having a particular behavior of the parent, right? Behavior of the parent, then or let's write it like this. Okay, or maybe I can just copy paste interface segregation. I'll just copy paste the definition. Okay, so let's take this definition and then modify it accordingly. Okay, so I just don't want to play around the words too much. Okay, so you can see the interface segregation principle is a principle that states that code should not be forced to use method it doesn't need. Same thing I'm writing here. It states that if any particular child isn't intended to be having a particular behavior of the parent, then it should not be forced to have that behavior. Right? It should not be forced to have that behavior. Right? That's where interface segregation principle comes to the picture. You can see more definitions. For example, if you go to Wikipedia, you can see states that no code should be forced to depend on methods it doesn't use. Right? So more or less, if I like define ISP in one word, that there should be no force of any behavior, or I would say no forceful implementation of any behavior. Right? You can see we were having forceful implementation of castling here. We are having forceful implementation of UPI payments. We have forceful implementation of do refund, right? Because Diners doesn't do refund, right? So this is where interface segregation principle comes from the picture, that there should not be any kind of a forceful behavior implementation. And you can see there is a forceful behavior implementation here coming up into the picture. Now, the best part about interface segregation principle is that the solution to interface segregation principle violation is pretty simple. Let me show you. What we can do is, again, we can have a credit card class. Okay, we'll copy this class and paste it here. Okay, you can see we have a credit card class again, right? Let's start with the same credit card class again. But this time, what we are going to do is, we are not going to have any behavior which will be forceful to anybody. We are not going to have any behavior which is going to be forceful to anybody. These behaviors are common. We will keep them common here. Apart from that, let's say if I create a Diners credit card .java, right? Diners credit card, let's say extends credit card. right? And let's say it is going to override the remaining set of methods. Okay, it's going to override the remaining set of corresponding methods. Okay, cool. Same copy paste I'm gonna let's say do for one more card. Let's say I'll create all the cards very quickly. Visa credit card .java, and for now we will just do it for common implementation. Extends, let's say, credit card for Visa. New file, MasterCard, thanks to Copilot. We don't spend a lot of time in writing. Extends, let's say, credit card again for MasterCard. Just two more. New file, Rupee credit card.java. Extends, and let's do credit card again. And last one, new file Amex. And let's say I'll believe we can live without Amex. Okay. Okay. Now, what we can do is, now in the credit card abstract class, we are only having those behaviors which is mandatory for everybody. The moment there is any deviation or any forceful implementation, what we are going to do is we are going to make separate interfaces for it. And that's the name, interface segregation. That if there is any behavior which is not common for everybody, segregate that into a new interface. For example, I can very easily get a new interface, and let's say we can name that interface as UPI compatible credit card. UPI compatible credit card. Now we have to create an abstraction. Now we have two options. Should we create an abstract class or should we create an interface? We should not create an abstract class. Why? Because Rupee credit card is also a credit card and it is also a UPI compatible credit card. But we cannot do multiple inheritance in Java. Sad. So the obvious option goes to an interface. Obvious option goes to an interface. That you say void UPI payment. And now only Rupee credit card is going to implement the UPI compatible credit card. The moment it does that, it is going to override your UPI payment method. As simple as that. Then let's say you are going to have a refund compatible credit card. You have a refund compatible credit card and it's an interface which is going to have a method void do refund. And everyone is a refund compatible credit card. Implements refund compatible credit card. Oh, sorry, not this one. My bad. This one, diners. Refund compatible credit card. Right. MasterCard is also a refund compatible credit card. Visa is also a refund compatible credit card. But your, let's say, diners is not. Rupee is also, and now you can see Rupee is also UPI compatible and let's say refund compatible, right? Refund compatible. Okay, but diners is not refund compatible, right? So we can remove it from diners. I added it in diners also. Diners is not refund compatible, right? Diners is just a normal credit card, and so on. Similar to this, you can have a pin based international payment interface and a non pin international payment interface, and so on. So you can see, definitely our code is in a better situation. Definitely our code is in a better situation. Can I say that? Our code is in a far more better situation than we would have thought, right? So from the problematic code, this code definitely looks far better. Now, I would like to pause myself here and ask you a question. With this, now, of course, now our classes look far better. Do you still see any problems with these set of classes? So in the current implementation, there are two issues. First issue, and this is not something that you have to generally implement in an interview, but it is good to tell that, let's say later sometime, let's say Amex, there is a, let's say, or diners stop supporting tap and pay. Diners stop supporting tap and pay. So what will you do? You have to remove tap and pay from here. If you have to remove tap and pay from here, then you have to remove tap and pay from here, and you have to create a new interface for tap and pay and put it apart from diners everywhere. So a lot of code segregation will be required in case somebody stops giving the existing support. So if we are designing our classes, we can also keep in mind that there can be a situation where when a particular feature is supported by a class, which can be discontinuing its support later. First thing. Okay. There is one more issue. The second issue is we still have some code duplication. For example, if you see the refund logic, MasterCard, let's say the refund logic is as it is same in MasterCard and Visa. But let's say the refund logic is different in RuPay. But if the refund logic is same in MasterCard and Visa, if the refund logic is same in MasterCard and Visa, okay, you'll be having code duplication, right? You'll be having a code duplication. Can I say that? If you have same refund logic in Visa and MasterCard, but a different refund logic in RuPay. So if RuPay has a different logic, that's good. You have overrided that in the RuPay class. But if there is same logic in MasterCard and Visa, there's a lot of code duplication. Plus, let's say online payment, swipe and pay and tap and pay. This also has some common implementation. Then also there is a lot of code duplication. So we have two problems. First, what if the algorithms later change and somebody stops supporting? Second, we still have some code duplication that is currently existing. We still have code duplication that is currently existing. So the problem that we have currently in hand is there is a lot of code duplication. Like do refund can be same in Visa and MasterCard, but it might be different in RuPay. If you will copy the same code in the parent class, then also it will create a problem for you. That Visa and MasterCard can take the behavior from the parent abstract class. But let's say now Amex and RuPay has the same logic. So that same duplicated code will be present in the overrided method of Amex and overrided method of RuPay. So a lot of code duplication is there. Then code support is there. Like you might lose support later and so on. All of these kind of problems can be very easily solved using a design pattern. And if you remember, I talked about what design patterns are. Design patterns are coding solutions. Design patterns are code solutions to these kind of I would say code maintainability problems. So the maintainability problem is we are writing the same logic again and again. So if you are in a situation, I'll give you a pointer. Okay. If you are in a situation where you are implementing the algorithm again and again in a duplicated way, right? And there are alternatives also, like doing refund. There's an alternative way of doing the refund also, right? But you might be having same refund way also in some places, right? So you have multiple options of your algorithm. So in some class implementations, maybe the same algorithm can go, or in some other classes, some other algorithm can go. For example, let's think about with respect to, let's say, sorting. Let's say every class can have might have to do sorting. Two classes are doing bubble sort, one class is doing insertion sort, two classes are doing merge sort. So two classes that are doing bubble sort will be copy pasting the same bubble sort code. Two classes that are doing merge sort will be copy pasting the same merge sort code. The one that is having insertion sort, that's a separate class, so it is more or less happy. Whenever you are in these kind of situations, right, where you have multiple strategies to do something, you have multiple strategies to do something. For example, let's say you are creating a searcher. Okay, let's say you are creating kind of like a searching interface, and there are multiple ways to search. Maybe you can do an indexed search on your database, or you can do a search in your Elasticsearch DB also. You have a search engine in Elasticsearch, you have your searching there also. So you have multiple strategies to search. Whenever you come in these kind of situations, there is a design pattern called as a strategy pattern. There is a design pattern that is called as a strategy pattern. What is a strategy pattern and how do you implement it? Pretty simple. I'll make a separate folder for strategy pattern. Strategy pattern. What strategy pattern says is that if you have an different types of some kind of an algorithm, try to make a strategy for it. For example, we can try to make a refund strategy. Okay, first of all, let's delete this class here. Go to trash. I'll copy all of the classes from my example 6 better code. Okay, all the classes I've copied, and I'll give it a package, strategy pattern. Okay. Okay, cool. So now what we can do is, instead of having this refund compatible credit card going something like this, what I can do is I can make a new interface called as refund strategy dot java. Okay. And I can make this as an interface. I can make this as an interface. Okay. Inside this interface, I'm going to have a function do refund. I'm going to have a function do refund. Okay. And we are going to make multiple refund strategy algorithms. So new file. So let's say one is a one refund strategy is same account or same instrument refund strategy. What is the same instrument refund strategy? That you are going to do a refund and you will do the refund in the same instrument. Like you made a payment through a Visa credit card, you will get a cashback, or I would say reversal of the payment in the same card. Okay. So let's say public class same instrument strategy, and it implements your refund strategy. Okay. So this is an algorithm to do the refund. Another algorithm to do the refund can be, let's say, bank account refund dot. And again, don't think that like actually these are the strategy. I'm just hypothetically creating it. Okay, like in Swiggy also and everything, you might have seen that sometimes they give you a refund in the Swiggy wallet, sometimes they give you the refund in the source account, and so on. So let's say there is a bank refund strategy. There is a bank refund strategy which implements refund strategy. Okay, so now you have two algorithms to do the refunds. You have now two algorithms to do the refund, right? Now what you can do is, you can see here in the let's say MasterCard. In MasterCard, you can have a private, let's say refund strategy. Okay, private refund strategy. And you are going to, when you will create the MasterCard class, then you will tell the refund strategy. When you will call the constructor, then you will tell the refund strategy. What is this mechanism called? I will talk about that. There's a formal name to it. But let's say you put the refund strategy here. And inside your do refund function, right, you say this dot refund strategy dot do refund. Okay, this dot refund strategy dot do refund. And in your Visa credit card also, let's say you say public refund strategy. And here, let's say for a moment, like I'm not passing in the constructor, let's say I say new bank account refund strategy. And for MasterCard also, let's do that. Let's not get it in the constructor for a moment. I'll say new bank account refund strategy. Okay. And here also, I will say this dot refund strategy dot do refund. Whereas in RuPay, I will say refund strategy new What was the other strategy? Same instrument strategy. And here also I'll say this dot refund strategy dot refund. Now, can you see? Currently, Visa and MasterCard both are using the same bank account refund strategy algorithm. Have I implemented it twice? No. I only have it implemented once. So whenever you have to implement multiple algorithms to do the same thing, you go with strategy pattern. So in strategy pattern, whatever is the algorithm, you make an interface for it, and then you try to make implementation of the interface for writing the core algorithm, one for each. And then wherever you have to use the algorithm, you use composition. So here we are going to have a refund strategy. So Visa credit card has a refund strategy variable with itself. This refund strategy variable will be getting the object of the corresponding algorithm, and wherever we want to call, we can just trigger that algorithm altogether. And the same thing you can do for other type of implementations as well, right? For example, let's say currently it's for refund. Let's say for international payment also there are multiple algorithms. You can have it in that way, right? Apart from this credit card situation, there can be other situations. For example, let's say there is a hospital management app. In that hospital management app, you want to list the doctors. Now, listing the doctors can be done in multiple algorithms. Like you want to list the doctors based on their rating, or you want to list the doctors based on their let's say availability. You want to list the doctors based on their experience. So there are different algorithms to do the sorting. Strategy pattern can come into the picture, and this same hospital management situation was there in my machine coding interview of Flipkart. So a direct application of strategy pattern in this example as well. Now you can have a rook movement strategy, and your rook can have a rook movement strategy along with a knight movement strategy, and so on. So like this solution can also be extended with your interface segregation principle plus strategy pattern as well, right? To implement, like this will be a straightforward interface segregation principle, right? You can have a rook movement interface, knight movement interface, and your rook can implement your rook and knight movement interface. But to implement that interface, if the algorithm is same, then the algorithm can be implemented in the form of strategy pattern, right? Okay, this is something that you have to keep in mind.